then you write your notes. If you have not understood means first you ask the questions, then you write your notes. Okay. So first focus clearly, because this is easy to compare. Very simple to compare and easy to compare. So here one of the question is, what is gradient descent, sir? So gradient descent is also one of the type of like similar to OLS. Okay, in the OLS technique, we are working on the ordinary least squares method, where we are going to focus on the least squares, that is sum of the squares of errors. Similarly, in the gradient descent, we are going to focus on the minimum error. Okay, that is one of the another way of technique. Okay, so either we can go with linear least square methods or gradient descent. Of course, gradient descent is one of the most important one and 100% guaranteed interview question. But that part we are going to discuss during the neural networks. In the deep learning, we are going to apply that concept. That based on that only the entire neural network was designed. So at that time, I'm going to explain the gradient descent clearly. Is that okay? Mirza. Done? So in the neural networks also, in the deep learning also, in the deep learning is a combination of both ML and AI. Means, for example, in the ML, we are going to work only on the structured data. In the ML, we are going to work only on the structured data. In NLP, we are able to work only on the text data. In the CV, computer vision, we are able to work only on the image data. Okay, text or audio data. Audio data also will be converted to text, then only it is going to process. Videos also similarly, videos also will be converted to images, then only it is going to process. Video or image or text or audio, it is both are same. So here it is going to work on the NLP is going to work with respect to text data. CV will work only on the image or video processing the data. ML work on the structured data. Deep learning is a combination of all of this. In the deep learning, we can work on the structured data. We can work on the image data. We can work on the text data. We can work on the time series data. Everything we can work, and we are going to work also in the future. Okay, one by one, once we complete everything, we'll come into that. Okay, how to process that one. In the deep learning, the way of approach is entirely different. Sir, in ML structured data we are working now. Then what is the difference here? Here also the same regression concept. Here also the same regression concept. But the way of approach will be different. Means each, for example, you want to move from here to here. One person is going like this. One person is going like this from here to here. One person will go like this. One person will go like this. Finally, destination is from here to here only. And if you want to go from here to Delhi, from Hyderabad to Delhi, one person is going to go on car. One person will take train. One person will take bus. One person will take flight. Different way of transport, right? But which one is best, miss? For your situation, whichever is best. For example, I'm having with respect to less amount only. With this less amount, I can't depth the amount and I can't go on the flight, right? Whatever the amount I am having, based on that, for example, flight is good or train is good or bus is good or car is good, miss? How you are going to say? Which is good, miss? Flight only obviously will be good because it is going to take less time. But money-wise, if you see, if I am a student and I am having only monthly of 2,000 or 3,000 from my home, like this I am getting, assume. Of course, now it is not 2,000, it is 10,000. Okay, earlier when I am studying, it is 2,000 or 3,000. Okay, now what are the amount we are getting of per month from the house, that is 10,000 rupees, and in that only we are going to save something, and now we want to travel on the flight, means it is highly impossible. So in that case, we are going to have only on the trains or buses or something. For our budget, which is the best one, miss? For our budget, which is the best, miss? As per our requirement, anything is going to solve, and which is satisfying our budget, that is the best one. Similarly here, which is the best, miss? You have to apply all of them and you have to try which is the best. For your given data, by seeing the data, sir, okay sir, by seeing this one, which algorithm is going to fit and which will give the best answer, we can't decide directly like that. Okay, if you can decide like by directly seeing the data, every project will be completed in one day only. Okay, we have to apply only one algorithm, one model, and we have to finalize that one, right? By seeing itself, like computations, whatever the computations we are entering in data science, like 1 hour or 2 hours computations will be there. Similar to that, it will be completed the entire projects. But generally, data science computations will not be of 1 hour or 2 hours. There will be no time limit. For data science, generally, there will be no time limit. And data science is an open book competition. Copy from wherever you want. Because though you copy also, after copying the code, the output you are going to get now, that how you are analyzing, that is more important. Getting the output is not important for the data scientist. Getting the output is important for the Python developers. For them, the code, they have to write the code and they have to get the output. Finally, they have to get the output. Whatever the code they are going to write, it is irrespective, but they have to get the code. Once the code is tested and it is positive and there is no error in that means it is happy. But for data scientist, we have to get the output. After getting the output, what you have understand, that is more important. How you have understand that one and what you are going to make from that. And at the end, what you are going to do. Right? That is more important for us. Right? Everything we are going to see one by one. First, NLP, natural language processing, and CV stands for computer vision. Right? So we are going to see one by one. You don't need to worry. Right? Just focus on whatever the class we are completing, the syllabus. Make sure whatever we are discussing in the class, you are perfect on that. Every day, make sure yourself till today, whatever sir has discussed in the class, we are clear on that. If you are making every day, that is the tick mark. So make sure what is the every day you have to get the only one question till whatever we have completed. Till whatever we have completed, till whatever we have completed the class, till now whatever we have completed the class, whatever the class was completed, we should be good. Every day, whether it is a tick mark or wrong mark, only two options. Yes or no. So make sure every day it is a tick mark. That is, every day you are perfect on whatever the topics we have completed. Surely at the end of the day, after 4 months, 100% you will get the interview call. And most of the interview questions, 90% of the interview questions will be in the class. Literally to say, if you follow my class, you will get the job. 100% job guarantee. Literally it is like that. But I can't say that job guarantee word because it depends upon the person. Whether they are by-hearting or whether they are understanding, I don't know, right? Yesterday I have explained so many concepts, but whether you have by-hearted that or whether you have understand that, I don't know. If you have understand that and if you are sure on that, 100% you will get it. Simple. Right? Now, let's move on to the next one. So today's, what is the thing is, just we have completed a linear regression task, allowing it to predict the future label values by given the set of futures. What are the, like TV, radio, newspaper, by giving as the input, we have identified what is the output, right? Now, how to improve on the linear regression model? Means in the MLR, multiple linear regression, we have got certain accuracy, that is R square value or RMSE value, whatever it is, we have got. Now, can we improve that for the same data? That is possible or not? That is, we are going to see. By here, there are two issues, polynomial regression. One is non-linear relationships. We are going to get into the non-linear. Non-linear means anything apart from the linear is a non-linear, any curve. So there are multiple infinite number of curves are there. Okay. Interaction terms between the futures. These are the two important words. Okay. First one is non-linear. Second one is interaction terms. Sir, what is meant by interaction terms? We'll see. Right? Now, for example, there is a scatter plot. You have observed a scatter plot between your X and Y like this. In this case, if you go with a straight line, like this, if you fit a straight line, that is linear relationship if you go, and if you apply the simple linear regression concept, a straight line you will get. Either this line or this line or this line, but one straight line. You are going to get one straight line. So now if you take this type of straight line, you are going to get more errors. You are going to get with respect to more errors. Why? Because the original Y and the predicted Y, the distance is large. So automatically the prediction line is very large, means automatically you are going to get more errors. This one is error, 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 error. So you should not draw a line like this. Always a line, whatever the predicted line, you have to draw a straight line, because this is the X value, this is corresponding Y value, and this is the corresponding Y hat value. Y and Y hat. Always straight line, 90 degrees line. Okay. So this is the corresponding X value and this is the corresponding Y value. X value, Y value, X value, Y value. How you are going to draw this point? This point is based on this, but this is actual X and this is actual Y, but this is the predicted Y based on the prediction line. So you are going to take with respect to the difference. If you calculate the difference, you are going to get for each of the data point large amount of error. Now in this case, if you go with a simple linear regression, then automatically you will get the error, more error. So now X is there, Y is there, both are continuous, and I want to expect the relation between both of them. And if you go with the simple linear regression, and if you fit that one, you'll get some answer. Answer you'll get. But that accuracy, whatever the accuracy you are going to get, is that correct accuracy or can you improve that accuracy? Now I want to improve the accuracy by selecting. If I select a best fit line like this, something like this, if I select, now which will have the less errors? Automatically the line which we have drawn, this one. Now this curve is nothing but a non-linear curve. So you have to fit with a non-linear. Based on the given data, we are going to fit accordingly. If it is able to fit with a straight line, means fitting with a straight line. If it is able to fit with a curve, means curve. Sir, how we will understand whether we have to fit with a straight line or a curved line? If it is a simple linear regression, by seeing the scatter plot itself, we are going to decide. But if it is a multiple, in the real time, we are going to get only the multiple data. Multiple inputs will be there. Now in that case, how we can decide? Some of the scatter plots will be looking as linear and some of them will look as non-linear. So how we can decide then whether to fit with a linear one or non-linear one? Means we are going to apply both of them. We are going to apply both of them. By, remember, for a given data, we have to apply, at least in the real life, we are going to apply minimum to minimum 50 models. 50 models minimum we are going to apply, maximum of 200 models also. And for the given data, whatever the new TV, radio, newspaper is there, for the same data, I am going to apply 60 models in this class only. In this class only, I will apply 60 models on the same data and I will show you which is the best one. If you want, you can write also, not a problem. Today itself, we will cover 20 models. How, sir? We'll see. Models is nothing but identifying the best one, right? Now, let us go into one by one. Keep in mind, this is an exaggerated example. It is not every future will have the relationship at higher order. It is not meaning that everything is polynomial or everything is linear. Some data sets will be like that. Some data sets will be like this. At the end, I want the answer who will give the best. Now, let us now consider some interaction terms. Now, what is polynomial regression? This is the one which I asked you to focus now. Clearly, please focus. Linear regression. So, I'm going to take TV, radio, newspaper. The same example, whatever we have done. Since I'm having 3 input variables, these are the inputs, 3 inputs and 1 output, which is called as sales. And I have identified the relation between them is y hat is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. This is the equation. And this is the linear relation. And I identified what I identified is beta naught value, beta 1 value, beta 2 value, and beta 3 value. First, after fitting the data, I have got these values. Now, whatever the values I have got is based on the OLS technique by default. It is applied OLS technique and it is identified which is the best fit line, means which is having the sum of the squares of errors as the minimum. According to that, it has identified. Okay, fitted. Fitting is done with OLS technique and identification of these things are completed. Next, what we have done is we have calculated the R square value of train and R square of test. Similarly, RMSE of train and RMSE of test. And we have evaluated for the given data. This is evaluation. Okay, this is called as modeling. And this is called as evaluation. We have done. This part was completed. And we have identified based on this linear regression, if I want to apply multiple linear regression for the given data, this is the maximum which I can do. Than that in linear regression, I can't do. That we have concluded yesterday. Than that we can't do in the linear regression. Nothing can be done for the given data. For the given data, if I apply the linear regression, the maximum I have done. Okay, than that better I can't do anything. Now, If I move on to the next algorithm for the same data, that to train test bit is also same. Data of train data and test data also should be the same. Then only you can compare between the algorithms. Now I'm going to apply the polynomial regression. Again, I'm going to take same input, constant, same TV, radio, newspaper. Okay, output is also same. X train, X test, Y train, Y test also same. As it is data, no changes in the data. Now the equation is going to change. What is the equation I'm going to take is in terms of data not, that is common. Intercept value is always common. Now here I want to increase instead of linear, non-linear, that is degree of 2. First I will try with degree of 2. Degree is equal to 2. What is degree is equal to 2 means? For example, let us go with a simple example. First I'll explain with a simple and followed by this one, the same one. If you are having one simple linear regression equation, that is y hat is equal to beta naught plus beta 1 x. Now same simple non-linear regression, simple linear regression and simple non-linear regression. What is meant by simple? You are having only one x value. For that, y hat is going to be beta naught plus beta 1 x as it is plus beta 2 x square, which is degree of 2. If degree of 3, beta naught plus beta 1 x plus beta 2 x square plus beta 3 x cube, you are going to add one more degree for that. That is the only thing. So like this, how many I can add? Degree of 2, degree of 3, degree of 4, degree of 5, like this, how many? Infinite. So then how you are going to apply in your concept then in using the code means for loop. Apply the for loop from the degree of 1 to 100, 2000, 10,000, whatever the number you want. For each degree, one model. If you write from one degree of 1 to 50 means 50 models is ready na, in one shot. Got the point? Now which degree is best for your data miss? I have to check the difference between R square and which is giving the highest one, either not overfitted or underfitted. Okay, neither overfitted or underfitted, first option I am going to see. Second option, which gives the maximum test accuracy, which is equal to the cross validation score. That particular degree I am going to finalize as my model of polynomial. Like that I am going to identify. This is called as tuning. Tuning means identifying the best one. Tuning means identifying the best one. For tuning, very simple example, I'm saying this is one of the most important. Without tuning, you can't get. So guys, please take a note of this first. Okay, please take a note. Actually, I thought everything can be explained in the one slide only, but it is going to take. So please write first linear regression very clearly in your notes so that I'm going to erase this part. Only linear regression, please write everything clearly, step by step. If you are having the doubt, please ask me clearly now itself. Within the linear regression, if you have any doubt, just you are applying the this only equation. Always equation remains fixed. For 3 variables means 3, 4 variables means 4, 5 variables means 5, 10 variables means 10, 20 variables means 20. But power is going to be 1 only. X to the power of should be 1 only. It is fixed. Linear means fixed equation. Since it is a fixed equation, that is the reason assumptions has there. Whereas other equations never are fixed. Only linear regression is the only one which has been fixed. Clear, guys? Yeah, I'm seeing some of the questions. Sir, can't have number of splits, n splits is equal to 5 greater than number of samples performing cross validation. So whenever you're asking this coding related question, you have to share me the entire code. Because before to that, what is the things you have selected? I don't know, right? By seeing the error itself, we can't confirm. Please share me the code. How to share the code? You can take that Jupyter notebook. You can upload directly in the Google Classroom in the comments, or you can share to me my personal number. Yeah, please share your number. I will share. Like at the end, I will share you. Okay. Is that clear, guys? Whenever you are asking any coding related questions, please make sure that you share me the before whatever you have written. Because whatever we are going to write in the data, it is going to depend on the previous data. So whatever the previous data you in the previous cell, whatever you have written, I don't know, right? I have to check that one also. If this is error is getting and I'm rectifying that error, and automatically still the error is not rectifying, means in the previous line of code, something is there. That is the reason it is not getting rectified here. So I have to see the previous code also. Without saying that, I can't tell the answer. Theory question, anything can be discussed, but coding question means code without seeing the code, I can't say. Is done now. So linear regression, I'm just erasing the only linear regression part. Whatever we have done yesterday, the same thing I have written, and I want to compare only. So if you observe tuning means I told you identifying the best. For any algorithm, you have to do the tuning. From now, whatever the algorithms we are going to discuss, each and every algorithm, we are going to do the tuning. Tuning means identifying the best. Best means there will be certain parameter. We are going to change the parameter for different values. For different values, we are going to change and we are going to identify which is the best. Now, sir, can you tell me with a simple example? Radio. Radio means not this radio, which is the column radio, original radio. So in the radio, we are having the radio and we'll be having some tuning like this, where we are going to rotate this knob and we are going to identify the perfect one. Nowadays, in the mobile phone, we are having auto tuner. So auto tuner is going to select automatically the frequency it is going to select. But if you go with manually, now here, the tuning, you are going to rotate this one. So for example, you want to go with 93.5 FM, 93.FM. Is there it is available, right? Okay. In my BTech, it is available. Now it is available or not, I don't know. Okay, fine. So 93.5 FM is there. Now you are in the 91. In the 91 position. 91 frequency or in your radio, it is 91 degree. 91 is there. So what you are going to do is, at the time, we are not having the smartphones. When I am studying in my degree, there is no smartphone also. Okay, there is no Jio, there is no smartphone, nothing is there. At that time, it is, don't think that I belongs to 1980s. Just 10 years back only. But at that time, still the smartphone was not there. Okay. So at the time, we used to have the radio also. Still this type of radio we exist. And I have used in my room also. In my SR Nagar room also, I have used the same thing. Right. Now, here we are having with respect to 91 frequency, whatever we are having, we are going to tune that one. Means we are going to rotate the knob slowly. And wherever we get 93.5, there we are going to stop. For example, 93.4 means sound will be very good. We'll get the sound, but it will not be that much of clarity. Some between some noise will come like that. If you go with 93.6 also, again noise will come. Exactly at 93.5 perfect frequency, if you tune means, then only clarity will be there. Full of clarity will be there without any noise. The same way we are going to do here also in the machine learning tuning. So we are going to take different values. With this value, the value is very close, and with this value, the value is very high. In between only some value is there. Again, we are going to identify like that. Moving to forward, backward, and identifying the best one in the, which is going to give the perfect one. In the same way, in the machine learning also, we are going to do. That is called as in machine learning also tuning only. Tuning means identifying the best one, best parameter. In the polynomial regression, the best parameter is degree. Identify the best degree value. For identifying the best degree value, you are going to try with multiple degree values. For my given data, what is the best degree? I also don't know. I am going to apply the for loop. One manually I can do, or I can apply with the for loop. Automatically it will only do one by one, right? So identifying the, you are going to tune the data, and after tuning, you are going to identify the best parameter, which is the best parameter, which is going to fit for the given data, right? Now this tuning is called as parameter tuning. And the parameter, whatever the parameter you are tuning is the model parameter. So here the degree is the model. So based on the degree only, the poly is the word of the degree. Poly means, what is the meaning of poly? Degree. So since you are working on the directly on the machine learning parameter, which is the algorithm parameter, it is called as hyperparameters. Okay, hyperparameter tuning means this one. Hyperparameter means model parameter. You are going to change the model parameter by one after one, and you are going to identify which is the best one. It's called as hyperparameter tuning. It is one of the interview question. And without doing hyperparameter tuning, you can't get the best accuracy in the real life. For every algorithm, you have to do the hyperparameter tuning, mandatory. Okay, such an important topic. Clearly understand that one. Hyperparameter tuning means very simple, taking with different values, identifying which is the best one. Okay, I'm going to show you with the example. I will show you and I will apply that one. What is the code, backend code, and how to write? If this is the combinations, how to write everything, I'm going to show you one by one. Now, let us enter into the next one. Now, here we are having with respect to simple only one variable x. For one variable of x, y is equal to ax plus b is the simple linear regression. Y is equal to ax square plus bx plus c is the polynomial regression with degree of 2. Y is equal to ax cube plus bx square plus cx plus d is the polynomial degree of 3. Y is equal to ax power 4 plus bx cube plus cx square plus dx plus e is the degree of 4 for the single variable. Now, question is, single variable is very clear, simple, everyone will explain. Now, two variables I am going to have, x1 and x2. Now, what we have to do? Y is equal to a1 x1 plus a2 x2 plus b, right? Which is nothing but beta 1 x1 plus beta 2 x2 plus c, beta naught in our case. In here, if you observe, I want two things now, ax plus b for the first one, second one, cx plus d for the second variable. Now, if you combine ax plus 1 plus cx2 plus b plus d I'm going to consider as z something. ax1 plus cx2 plus z, anything is same only, na? This one and that one also same. Only notation is changing. Just you are adding two variables, combiningly you are combining two variables side by side. Is there anything different? Are you feeling any difficulty? Don't think of beta naught a1 like this. You don't think. Obviously, you'll confuse because here I am considering a, c, and here I am considering a1, a2 like this. I am considering this. You'll confuse. Don't focus on the notations. Focus on the x values. Here only one x variable is there. So here second x variable. Two variables you are combining. This is for one variable. This is the equation. Means for two variables, this is the equation. Now you have to tell me. Let me write like this. Still more clearly I will write. Notations is as per our choice. For example, a plus b whole square. What is the a plus b whole square? Means one person will say a square plus b square plus 2ab. C plus d whole square. C square plus d square plus 2cd. Both are same only, na? Notations only changed. Okay, don't focus on this one. Don't by heart what is meant by a plus b whole square. Don't by heart the formula. Understand the concept of a plus b. A plus b means a plus b whole square means a plus b into a plus b. A into a is called as a square. A into b is called as ab. B into a is called as ba. And b plus b is b into b is called as b square. Where a square plus 2ab plus b square you have got like this. If you understand that concept, anything here you are writing is also same. If you understand only a plus b whole square and you by heart that one means automatically notation changes. Sir, maths is difficult, na? Maths is a difficult subject. You'll think like this. Okay. So notations only changing. These are called as notations. Notations means different values. Okay. So in my notes, I will write with different notations. In one page, I will have one notation. In another page, I will have one notation. In which page, which notation I'm going to write, I also don't know. Just I know only one thing is concept. Linear regression, if this is the equation for one variable, means for two variables, what is the equation? That is x1 and x2. What is the equation? I will write like this. Y is equal to ax1 plus bx2 plus, ax1 plus b plus second variable cx2 plus d, which is a combining law of ax1 plus cx2 plus b plus d. I'm going to take it as z. Some name it as z. Z is the ultimate one, na? Last letter. No problem. So that is the reason I'm fixing the z. I don't need to disturb every time the z value. Intercept is always fixed with z for me. Now, sir, same equation, if you are having x1, x2, x3 variables, three variables are there. Y is equal to ax1 plus b, first one completed. Second one is cx2 plus d. This one also completed. Third one is ex3 plus f. This one also completed. Now the equation is ax1 plus cx2 plus ex3 plus z. Combining it, which is nothing but beta naught x1, beta 1 x1, beta 2 x2, beta 3 x3 plus beta naught. Same. Completed. This is for one variable. Now, similarly, this one, quadratic for two variables. Let us go. Y is equal to for ax1 square plus bx1 plus c for first variable completed. Second variable. What is the second variable? x2. Similarly, dx2 square plus ex1 plus f, which is nothing but ax1 square plus bx1 plus dx2 square plus ex1 plus z. This is the quadratic equation for two variables. Sorry? ex2. Is that clear? Now tell me for three variables, same quadratic equation. ax1 plus ax1 square plus bx1 plus c, that is dx2 square plus ex2 plus f plus gx3 square plus f hx3 plus I. If you take off these three into one of z, now remaining balance is ax1 square plus bx1 plus dx2 square plus ex2 plus gx3 square plus hx3 plus z. Simple. Got the point? Is that clear right now? 4 variables are there means 4. 10 variables are there means 10. 20 variables are there means 20. Simple. Add of everything. Linear means adding. Every time add. Plus only. Plus symbol only. Plus symbol is fixed. Regression concept is with respect to plus symbol. You are not going to change. So in between into, you are not going to get like that. Quadratic. This is called as quadratic equation. This is called as cubic equation. For the cubic equation, there is no multiplication symbol or division symbol or minus symbol. Is nothing is there. Simple. Is that clear now? For 2 means 2, 3 means 3, 10 means 10, 20 means 20. Whatever the equation, you are going to write. Right? How many variables we take, sir? So in the given question, TV, radio, newspaper is there means 3 variables. In the given equation, in the given data set, 20 variables are there means 20. 500 variables are there as the input means 500. Okay. So here just it is applying like that. Similar way, for the same cubic equation for 2 variables, for 3 variables, for 4 equation, for cubic and for 2 variables and 3 variables. If you write like this, it's the same thing. Is that clear? Now, next one is, here the most important concept come into picture is, for 2 variables, we are having this one. But what if you observe what is the highest degree? Degree of 2. Because quadratic equation degree will be 2. For cubic one, degree of 3 only will be there, maximum. But here I'm adding one more variable called as x1 and x2. Because this one also combination is degree of 2 only. So with the degree of 2, this is also combination is possible. So from where you got this one? If you take with a plus b whole square, a square plus b square plus 2ab, which is degree of 1. So this combination gives you the square. Similarly, a plus b whole cube, a cube plus b cube plus 3a square b means 2 power 3 plus 3ab square, again power 3. So which is going to give the power 3? That combination you have to apply when you are having two variables. If you are having a single variable, that combination will not be there. This combination is called as interaction terms. This combination is called as interaction terms. Okay, what is meant by interaction terms? Now, it's a combination. So if you take TV, radio and newspaper, okay, and if I apply the quadratic equation with a degree of 2, now what is the equation? A into TV square plus B into TV plus C. Similarly, D into radio square plus E into radio plus F plus G into newspaper square plus F into, sorry, not F, H into newspaper plus I. So this is the equation which we have discussed in the previous slide just now. Now in this equation, if you observe here, only TV, effect of TV you can see, only effect of radio you can see, only the effect of newspaper you can see. But combination of TV and newspaper, how it is going to affect, how I have to see. So that is the reason I'm going to add with respect to J into TV into radio. Similarly, K into TV into newspaper plus L into radio into newspaper. Now I'm going to get A value, B value, D value, E value, G value, H value, J value, K value, L value. Out of this, which value is high, that is the affecting the model very clearly. Which model, which is the best one, miss? Which value, which slope value is more, that is the best one. That term is best one. Sir, here if you observe, actually I got only TV, radio, newspaper. These three columns only they have given to me. But I am going to create a new column with TV square. Can I create a new column which is multiplication of TV into TV? Can I create? Radio square. Can I create? Newspaper square. Can I create? Next, I am going to create a new column TV into radio. Can I create? Can I create with respect to TV into newspaper? Can I create radio into newspaper? Actually, this is the data they have given. These are the 6 columns which I have created. Now I am applying my output variable says over 9 columns. I am applying linear regression only, but 9 columns I am considering. Now what is the equation? Just first one is TV square, A into TV square plus B, TV into B into radio plus C into newspaper plus D into TV square plus E into R square plus F into NP square plus G into TV into radio plus H into TV into newspaper plus I into F G H I into radio into newspaper plus finally whatever the final Z. Just I am applying the linear equation only, linear regression only, but taking the additional terms this one. Earlier I have worked only on the 3 input variables. Now I am going to work on the 9 input variables. I am going to identify the relation between 9 input variables versus output variable. Clear? Is that clear? Getting confused? Okay. So for example, if someone gives me 200 for TV and 150 for radio and 50 for newspaper, what is the answer, miss? I'm going to collect first this one and I'm going to calculate for 200 square also I will calculate the value, but for 150 square I will calculate the value, for NP square I will calculate, for all this I will calculate and I will substitute the values here along with the intercept and coefficient values. And I'm going to predict the y hat. What is the estimated value? Is that clear? Data is same, but newly you have created. What is the difference between yesterday's and today's, miss? Yesterday you have considered only with respect to A into TV, B into radio and C into newspaper plus directly Z. Miss, you have taken only this one with respect to this one. But this time I'm adding this one and along with this one. Earlier we have considered only up to here. But this time you are adding these things. That's it. Nothing else. Okay. So by doing this one, sir, why we are doing all these things? It is getting confused now. Why we are doing all these things? Miss, if I tried in this way, maybe our value increases R square. Who knows? Right? I want to try in that way. Sir, okay, you are trying in that way. Fine, sir. But who asked you to do in this way? Again, question. Nothing. You are going to try with multiple ways. The existing algorithms you are going to apply. No, sir, for my data, if I don't consider radio miss, then only I'm getting perfect answer, sir. Drop. At the end, remember, I want the test accuracy should be very high and along with the cross-validation score. That is more important. In what way you have done, that is not important for me. If you want to drop any particular column miss, you have to statistically prove. Without dropping of any column, you have done, sir, I have not even dropped one record, sir. One value also not dropped, sir. But this time, the algorithm I have invented, sir. Not this existing one. I have invented my own one. Happily. In the company, we'll do that one. We'll do that one. You will also going to do some new things. I'm also going to do some new things. So some new things means automatically we can create the patent and something like this, na? But it is only applicable for the given data or it is applicable for generalized data. If it is applicable for all the types of different types of data means it is a patent. It is applicable only for your data means it is project. Done? What is the difference between a project versus with respect to a patent and with respect to article miss? So you are designing your own way and you are going to publish the articles. If you want to disclose to others miss, you are going to publish the article. In the company, whatever the projects we are doing, everything is some kind of articles. Articles means not newspaper articles. In terms of papers, journals. General articles are there, na? In the journals, whatever we are publishing, the same thing. In every company, every project is a journal, actually. But that company people don't want to disclose to outside. So they don't want to disclose means they are not going to publish as a journal. If they want to disclose to outside the world and I want to show that I'm having this much of content with me means they are going to publish the article. Tomorrow, if you want to get an MS seat means you have to publish an article. If you publish an article only, you'll get the MS seat. There is a high probability of getting MS seat in the abroad with a scholarship. Okay, I'm having 25 lakhs with me and I'm paying the MS seat miss. Okay, that is secondary. I'm not saying about the money wise. Subject wise, if you want to get the scholarship in the abroad, in the MS with respect in US or Germany or somewhere, wherever the country, you publish the more the number of journals. Publishing of more number of journals is nothing but you are having that much of subject, you are projecting yourself. Projection of subject is the general. Okay. So everyone will project themselves. Right? Is that clear, guys? Now these interaction terms, see, perhaps newspaper advertising spend by itself is not be effective sometimes, but a combination of TV and with respect to the newspaper will have more effective. The same logic was applied by the Lalita juries, Gundu boss. Same concept. First day he will publish on the TV. He will come in the TV and he will say that money you will not get for free of cost, like that, some dialogue. And next day he will come in the newspaper. What he is going to do is, first day he is going to give the advertisement. Next day he is reminding us. So whoever has seen that one and who wants to purchase, they will fix now something. Oh, this much of low cost. Someday he will come and he will say, as of now in the market, the gold rate is 52,000 something. 10 grams gold is 52,000 approximately. I don't know exact value. Approximately it is 52,000. He is going to say that I'm going to provide for today 51,000 only. He will come in the TV and he will say that I'm providing for 51,000. Assume. Now, by saying that, oh, 1,000 rupees saving. Actually, we thought to buy now. Now we'll buy. Who are ready? And that too in the next month, marriages will be there. Na? obviously more number of people are going to purchase. So they'll make sure they'll purchase the gold now itself in this month only. Okay, because next month marriages are there. So many marriages will be there in that month, particular month. So they are going to purchase. Now this analysis will be made by the jewelry shops. So whenever there is a thing like this, they'll come on the TV and they'll publish the advertisement. Now if you observe, more number of whichever the channels are having high TRPs, everyone will have jewelry advertisement. In this month, you will find more jewelry advertisements. Okay. GRT Jewelers, Khazana, like these advertisements will come more in this month particularly. Okay. Where in that too rate is low, miss, still it will come. And some people will have some kind of funds. They'll raise the funds. Like you can invest 5,000 for this month, 5,000 like this. Every month you can invest and at the end you can take the 10 grams of gold after 10 months. Different schemes they are going to come with, right? But all these things are combinations. How these combinations are going to work, miss, we have to apply and we have to see. So TV and radio, if you apply and if you want to observe, miss, you have to observe. No, sir, I don't want to do that one. I can't spend on TV one day and again immediately I can't spend on the newspaper. I'm not having that much of money, miss. Purely focus on TV. If you spend, how much you are going to get. Simple linear regression, you apply on the TV only. Only newspaper, how much effective it is going to be. Apply simple linear regression on TV. I mean radio or whatever newspaper. Individually, if you apply and check what is the result. It's a combination. And that too, these are the different combinations. Apply and check the result. And which gives the maximum accuracy according to that you are going to do. Okay. One more time, live example is with respect to that cryptocurrency, which I have done. The same example which I am saying is just a live example. One of the live example. Here in this particular, here we are having, if you go into this particular thing in the cryptocurrency, this is the live market. Okay. Here we are having with multiple things are there. Multiple coins are there. N number of coins are there. Almost to my knowledge, it is approximately 800 coins are there in this. Okay. In this particular website, 800 coins are there where you can purchase or you can sell whatever you can do. 800 coins are there. But which coin you are going to select and which coin you are going to invest, miss? Analysis you have to do, right? So I have done some kind of analysis and I have invested something. So if you observe, today morning, I have taken with respect to this morning at around 5 o'clock or 6 o'clock. In between that, I have done with respect to a new one. So why I'm showing this one, miss? In order to tell you that, see, this is the morning only I have done. Today morning. Okay, I have done today morning. I have purchased this one and I have sold one of them. And I'm having net profit of $200, which is 16,000. Okay, let's wait for $1,000 and I will book my profit. Okay, that is secondary. That we will leave that one separate. Now, the thing is that why I have selected this combination only? That is important question. Question is that one. Yeah. If you have money, you will also buy. But which one you have to buy? That is the question. Nah. Question is that one. Nah. Which combination gives you the profit? That is important. Every day I'm trading. Every day I'm doing something. Okay. If suddenly market falls also for me, no problem. If suddenly market rise also, no problem. Because one I have bought, one I have sold. Anything happens also, no problem for me. If I don't see also, no problem. If I see after 10 days also, no problem. There is some, when I have to enter, when I have to exit, there is some rule is there. That rule I have identified on my analysis. How you have identified means I have done the analysis. For that, I have collected the data of last 3 years. 3 years data I have analyzed. And based on the analysis, I have invested. Like this, I have invested with more things. So, for example, let me show you. Okay, I should not show all my secrets. Nah? Okay, let us leave that. Okay, I have done some more things. From last month, 26th, I have done with respect to whatever the investments I have done and whatever the analysis, different trades I have done, different things I have done. Finally, I have made a profit of around 4,500 rupees till now. Not rupees, dollars. $4,500 from last 26th starting date. So which is almost 10 days. In 10 days, $4,500 approximately, right? Exactly if you want more detailed image, I can even show that one also. Otherwise, you will not believe now. Okay, let me show you. Why I'm saying all these things, one only. The reason is one only. I'm not showing that I'm a great person or not, nothing like that. Here I want to show only one thing is analysis, combinations, which is going to give better, which is going to be best at that particular time. That is important. So here, if you go with everyone will ask, obviously. Everyone will ask with respect to show only. The analysis also, guys, it is too early to discuss everything. I will discuss. Because we are in the second month only now. So still 10 months, courses. Once we complete the machine learning, we'll have so many projects in our hand. We are going to analyze, we are going to predict, and I'm going to invest. And whatever the profits I'm going to make, I'm going to share to you. Right? You are going to be part of that. And I'm going to share my personal projects, whatever the projects I'm getting. So many things are there. Okay, if you are having the content, means so many things are there. Right? So here, the thing is, see, so first day I have made on 24th, first 24th I have started. At that time I have made with a profit of $448. After 463, $189, $257, $567. One time I have got a loss of minus $2,200. In one shot I have lost. Again I have lost with $2,000 immediately. Okay, $2,000 I have lost immediately. Again I have got with respect to $929, $1,469 in one shot I have got. This is combination of these two, which is a coins of these two coins. That is AAVE and SOL. One is Avalanche and one is Solana. Coin name is. And now presently, whichever the coins which I am trading as of now is ETC and GEN is the coins. Sir, at the time you have invested in that. Now we are investing in this. Why? That was completed. Target is completed. Now the rule is not matching. Completed. And it is going on in a different way. Now I have came out of that. This is purely an example. When I have invested and when I'm coming to this place on the way now, by that time I'm in the loss of minus $250. Minus $250 I'm in loss actually at that time. Now it is showing 190. And after within 10 minutes, again it may show $400 or it may show zero also. Okay, whatever it is. But at the end, I'm having with a profit, I'm fixed with a profit of this much of amount and I'm going to make that. So across 362 now itself. Okay. When 191, you only have seen, na? I have not done anything. I only refresh button I have done it. Okay. So wait for my target and I'm going to close. Okay. $362 and approximately it is 30,000 rupees morning. Right? If I do once again refresh, it may increase or it may decrease. I don't know. It is suddenly increasing. To my luck, it is increasing. You are thinking very positive about me, but sometimes it decreases also. Okay. So anything may happen. Chick, we should not see this one. Okay, let us leave this. And let us leave this and it will only book automatically profits. Okay, fine. Let us get into whatever we are discussing. What we are discussing, I am forgetting. Shit. Yeah, something polynomial regression. So now just a combinations. Just you are working on the combination. That is purely lucky, guys. I don't know. From 190 to 475 to go, I don't know. Okay, luck. That is pure luck. Okay, now, but end of the day, 1,000. Today, end only 1,000. That is for sure. But when it is going to get, I also don't know. Okay, fine. What is the thing? Polynomial regression. Just we are going to apply the different approaches and we are going to find. So just you have to take the combination. Just you have to apply the combination and you have to analyze. After analysis, you'll get some result and that one you have to make and based on that. Accuracy here is important. Okay. So in my case also in the whatever the coins and Bitcoin I am invested or whatever the things, accuracy. Based on the accuracy, I'm sure only then only I'm investing. If I'm not sure, I'm not going to invest. So whether to invest and what level of profit I have to take, whatever of the loss I have to book myself, everything is analysis. So analysis will be different from person to person. I have analyzed in a different way. You are going to analyze in a different way. I have applied some kind of machine learning techniques. You are going to apply some different type of machine learning techniques. Okay. So this concept, whatever I have applied here, there are also time series analysis only. But what is the time series I have applied is different. What you are going to apply is different. That thing makes the difference, everything. So just you have to apply the different concepts. Just you are going to take different concepts and different approaches. Is that clear? Just you are going to apply the different concepts and different approaches and different combinations. So now here, I'm going to start the polynomial regression coding part. Now you'll understand very clearly the same data set. Data set I'm not going to change. So local host will not work. Okay, so here NIT regression polynomial is. Okay, so here I'm going to start. First, I'm going to import the data. That is yesterday, whatever in the multiple linear regression, same thing. I'm doing the same thing. First, I'm going to load the libraries. Next, I'm going to load the data, same data. Again, I'm going to see the same info and same missing values, same describe, same pair plot, same correlation, and same X and Y. Up to here, nothing changed. Now, earlier, the X value, whatever the X I'm having is only the three, that is TV, radio, and newspaper. These only are the three. Now I'm going to increase to quadratic, degree of 2. So once I increase to degree of 2, automatically I'm going to increase more things like TV square. I have to create a new column called as TV square, radio square, newspaper square, and interaction terms like TV radio, TV newspaper, and radio newspaper. So total 6 columns has to be created. For creating this one, what I'm going to do is I'm going to take from sklearn.pre-processing, import the polynomial futures. You are going to import the polynomial futures, and polynomial converter is equal to polynomial futures of degree is equal to 2. You are going to take degree of 2 and include the bias is equal to false, means the last one intercept is there, that will not be included. So in the equation ax square plus bx plus c, I'm not going to consider this one, only x square plus bx. If 3 variables are there, ax square plus bx plus cx2 square plus dx2 plus ex2 square plus fx3. I'm going to consider only x1 square, x2 square, x3 square, x1, x2, x3. Already x1, x2, x3 is there. Now I'm going to add the squares, and along with that, I'm going to take x1, x2, x2, x3, and x3, x1. But I'm not going to consider this intercept value. If you want to add this, you add. So whether to be added or whether to not be added means again your choice. Try with that one and try with this one, both. Right? So here I'm going to take degree of 2, include bias is equal to false, means only with respect to the last one. Now I'm going to use this polynomial converter fit and transform on the x. On the x variable, I'm going to do fit and transform. Now whatever the fit and transform I have done, I'm converting this one to x underscore poly. I'm going to take x underscore poly is equal to pd dot data frame of this one. Now if you observe, now x underscore poly, so total now 9 columns you have got. Earlier, if you observe clearly, first one is 230, 37.9, 69.2. The same thing up to her, that one is common. x1, x2 and x3 is common. x2, x3 is common. This is x1 square, this is x2 square, and this is x3 square. And x1, x2, x2, x3, and x3, x1. Total 9 columns you have generated since you have taken the degree of 2. Now you are going to apply for these 9 columns versus sales. Now your X is this one, input is this one, output is this one. Apply the linear regression between them. Total, you are going to get 9 quotient values and 1 intercept value. Beta naught plus, beta 1, beta 2, beta 3, beta 4, beta 5, beta 6, beta 7, beta 8, and beta 9. 9 quotient values and 1 intercept value and with respect to the output. And you are going to do this. And once you apply, see X poly I am taking as the train test split. Now I am going to take X poly and Y and I am splitting. And now whatever the data I have got, if you observe the data, what is your X train? If you observe clearly, what is your X underscore train? If you observe the data, see total 140 records with 9 columns is the input data. What is the X list? 60 rows with 9 columns. 60 rows with 9 columns, right? So instead of going with 3 columns, now you are going with like this. Now the question is in the one of the question in online, they are asking why you are considering degree of 2 only. First I will try with degree of 2. Later I will come and replace with 3. I will write the number 3, 4, 5, 6, 7, 8, 9, 10 like this. If I am not able to write that one also, I will write the for loop. Automatically it will only take. Loop is there, repeating the same thing. So I'm going to apply the for loop for I in range of 1 to 500. Whatever number you want, you interested, you write. I'm writing only up to 10 only. For example, 10. I'm writing up to 10. And I'm going to write this degree is equal to I. First degree will be taken as 1. It will be done. Degree of 2, it will be done. Degree of 3, it will be done. Degree of 4, it will be done. Automatically up to degree of 10. Up to which number, maximum of which number you have to take, it will be decided on the first, up to 10 only you take. And you see the last number. For the last number, still it is not overfitting or underfitting, still the accuracy is increasing only, then you increase the degree. If there itself is the problem is there, means below only answer is there. I told tuning, radio tuning. You have to move. If you are not getting the noise miss, again you have to come back. If there is no noise miss, you have to move forward. How much you have to move forward, how I can know? Till you get the sound clarity only, we know. By listening only, we'll understand. We have to rotate the knob and we have to listen the sound is coming or not. Rotate the knob, listen the sound. Rotate the knob, return the sound. Same way. Right? So here I'm going to apply the linear regression with the total 9 input data. And if you observe the quotients, so total 9 quotients you are going to get. Out of which, if you observe clearly, this quotient is 0.05, 0.01, 0.01. This is 000. Means that much of impact it is not having. And 001. This is 000, 000, 000, 000. Means these are not having that much of impact. If you multiply with that also, there will be no much variation. So for example, 30 into 0.0003 means what will be the value? It is not going to have much impact, right? So now you are going to use the X train, Y train prediction, and you are going to predict the train square and test square. Yesterday we got for the same data, 78 and 76 approximately. Today we are getting 98%. Data was not changed. Algorithm has changed. The same input data, because I have applied the same time split, train test split, the same test size I have considered. At the same time, random state also already fixed. Now I'm going to apply the cross validation score. My cross validation score is also almost 98. Means it is a very good model where it is having neither overfitting or underfitting, but cross validation score is equal to test. So for degree of 2 of only you are getting like this. Maybe for degree of 5, we may get 100% also. Who knows? Try. Okay, we are going to try with RMSE. So whatever we have done, now everything just, since I am explaining for you, I am writing everything in a different cell. Tomorrow you are not going to write in a different cell because everything is yours only. So you are going to bring everything in one shot. That is degree of 2 like this. Polynomial futures you are going to convert. And you are going to do that train test split. And you are going to fit on the X train, Y train. You are going to predict on this one. And you are going to calculate the train score, R score. In one shot you are going to get. You are not going to write these many steps in real life. Because I am explaining for you, I have to write very clearly one by one, step by step. So this steps, whatever this is there, this indicates that I am doing the polynomial futures. Polynomial regression I am applying here. This step indicates for me train test splitting. This steps indicates for me with respect to modeling. This cell indicates predicting. This cell indicates for me checking the values, evaluation. So I'm explaining for you. So I have written in the separate cell. You are not going to explain to others in the real life. So you no need to write in the separate cells like this. Directly you are going to write in one cell everything and you are going to get. Now degree of 3, change to degree of 3. Shift enter. One shot, everything is done. Degree of 4, change. Shift enter. Degree of 5, shift enter. But in degree of 5, you can observe clearly, R square is now negative itself. Test R square is negative. Yesterday I told you, na, R square can be negative also. See, if you go with degree of 5, average line will be the best fit line. ANOVA test will fail. Everything will fail. Average line always is the best fit line directly if you go with degree of 5. So R square can be also negative. You can clearly see here. So now clearly indicates that either the answer is either 2, 3 or 4. Any one. So first you are tried with 2 and you are going to write the train R square, test R square separately. With degree of 2, degree of 3, train square, test R square separately. Degree of 4, train square, test R square. You see out of these 3, which is having the maximum. Fix that one finally. That is your final model. Right? So if you observe this one, for RMSC of simple linear regression, it is of 1.94, where polynomial degree of 2, it is 0.72. Such a drop in RMSC. RMSC should be low, accuracy should be high. RMSC means error. Error wise, if you come miss, it should be low. If you see accuracy wise miss, it should be high. Now we are going to take the bias variance trade-off. That is, see, I'm applying the same D in range of 1 to 10. I have copied as it is here. And whatever the answers I'm going to get, I'm going to append into an empty list. No need to write also. Manually, no need to write. Everything you append to an empty list. Take the list. Is this code, did I explain earlier or not? You know what is empty list and you know how to append into empty list. That I have explained during the for loops concept. How to append one after one value. See, the above, whatever the above is there, from here to here, this cell I have copied, paste here. First polynomial converter, after that fit and transform, after train test split, apply the linear regression, apply the prediction and calculate the mean square error and test RMSE and train RMSE, and whatever the answers you have got, train RMSE errors you append into the train RMSE list, test RMSE errors you append into test RMSE. Everything is done. Just I have applied the concept. You know what is meant by for loop. You know what is meant by this. You know what is meant by empty list. You know how to append. Combined. You are just combining everything. And now you got the tried RMSEs of degree of 1 to 9. Range of 1 to 10 means degree of 1 to 9. This is degree of 1, degree of 2, degree of 3 like this up to degree of 9. Similarly, test RMSEs of degree of 1 to 9. 2 degrees you have got simultaneously. Now you are going to take scatter plot, line plot. What is the line plot? I'm going to take X values and Y values. X values I'm going to take range of 1 to 10. Y values train RMSE and I'm making a line. So for degree of 1, what is the train RMSE? For degree of 2, what is the train RMSE? For degree of 3, for degree of 4, for degree of 5. Like this, I'm going to make the line. Similarly, for the again same X values, I'm going to take the test RMSE. Both are in the same cell. Automatically in the one graph only, I'm going to get both the lines. The same example I have shown you in the matplotlib also. By taking y is equal to x, y is equal to x square, y is equal to x cube. Everything I have shown in one cell only. Okay, do you remember? So just I'm applying. I told that whatever I have discussed earlier, I'm going to apply in the future classes. Data science is a interlinked subject. Means you have to remember the matplotlib class. If you have forgotten the matplotlib class, automatically today's code will be, sir, you are explaining somewhat faster. What I am explaining? What is there? What is the new thing I am explaining here? Just plot I have told you. Plot means line plot. For line plot, 2 input variables should be there. That is x comma y. When 2 lines are there, you have to apply the label and you have to write the legend. Everything I have explained. Na? Again, I have to explain here. Just apply that logic. So just I am going to do this one and I have got the plot. From the plot, it says that train RMSE is very low, test RMSE is very high by higher degrees. So I am going to take up to 4 only. So now we can see here, this is best converging at degree of 2. So almost test RMS and train RMS are very close to each other at degree of 2 and almost perfect data. So that I'm going to finalize my degree of finally with respect to 2, and I'm going to save this as my final model. For the given data, if I want to go with polynomial regression, degree of 2 is the best one. Like this, I'm confirming. And whatever the model I have confirmed, I'm going to save the same thing as the final model. But here you are going to apply some polynomial converter also. That one also you have to save. You have taken the converter, you have taken the transformations or something, you have to save that one also. Now, once you save this one, they are going to load from their end and they are going to check for 149, 22 and 12, what is the answer. If I invest 149 on TV, 22 on radio, 12 on newspaper, what would be the answer? And it is going to be 14.51 is going to be the answer. It is going to see by the client, and according to that, he is going to invest. The client will see that one and he is going to invest. Is that clear? Any questions? If you have any questions, you can please ask me. If you observe the code, every line of code you have already done. Either in the multiple linear regression or simple linear regression or separately you have done everywhere. I am combining them now. Now from this again, tomorrow I am going to combine so many things again. Furtherly, I am going to combine multiple things. That is the reason I ask you to make sure of yourself very clear. Now the question is, it is possible to take the degree of 1.6 like this. Try. Apply. What's wrong? Apply. Sir, here also we can get the summary. Yes, absolutely you can get the summary, because now the X is 10 variables, 9 variables you are having the X values. First you store them into X and Y and apply the OLS over Y over X. Automatically it is going to apply the simple linear, multiple linear regression only, but this time 9 variables. The same thing. Balgaravi. Right? You can apply and you can check. What is the role of estimator parameter in cross-validation function? Yes, you are going to do for everything along with the cross-validation also. So here I have done only test RMS, train RMS. You calculate the cross-validation score also. In the same thing, you apply that one. You take the cross-validation score also for every degree. What is the cross-validation? That also you store in the empty list, one more list. And for every degree, what is the cross-validation score also you check. Right? You add that one. While practicing, you add that one. Is that clear? Sir, error I'm getting. Maybe your model is configured. See, just you observe here very clearly. Whatever the model you are taking, see, the first one, X poly, I have converted to X poly. This X poly has to be given in this input. You should not give as X comma Y. X poly. This poly after total 9 terms is there, that 9 terms should be taken as the input parameter and it has to be divided. And the same, now after dividing, you are going to get in the extrain. From here, it is going to be extrain only. But here you have to give the poly. Otherwise, it is going to work on the original X only. Every time open the, if you are not sure, every time check yourself. X poly, what is there? Extrain, what is there? X, what is there? Check each and every variable, open and see how many variables are there in that. How many records are there? How many columns are there? Open that one and see. Is that clear? If you are having the same, for example, you are working on the 9 columns and you are asking to predict on 3 columns, means how it is going to predict? If you write to predict on the X poly only, it is going to predict. Total 9 columns also has to be given as the input, and for that 9 columns, 9 quotient values will be multiplied. And according to that, it is going to give the input. If you give only one column as the input, automatically error. Clear, guys? Right? We'll meet tomorrow and we'll see for the same data, one more algorithm. In the real life, for the one data, we are going to apply multiple algorithms. Whatever we can do, all the algorithms we are going to apply. Finally, we are going to decide which algorithm is best suited, and that algorithm we are going to save, and that algorithm only we are going to share to the client. Yeah, either you can go with R square value, or you can go with RMSE as per your choice. Anything of your choice, any one. If you go R square wise means it should be high. If you go RMSE wise means it should be low. Okay. Now the question is, Lekha, you want to share me the Jupyter notebook, right? Share me the Jupyter notebook on my mail ID. The mail ID is srk.datascience@gmail.com. You can share your questions to this mail ID. Share your Jupyter notebook to this mail ID. Don't share as a PDF format, directly share I'm not having that much of time. I'm not practicing person. So for me, no need of PDF. For me, I want only the Jupyter notebook directly, IPNB file. You guys have to practice. So that is the reason I'm sharing the PDF. You don't share the PDF for me because I'm not practicing. I'm rectifying. Right? So share me the IPNB file. So once I go through that, and I'll get back to you on the same. Like srk.datascience@gmail.com. Lakreddy Narasimha Reddy is saying that STS class, Omnibus, that is not required. We are not going to focus on the AIC or Omnibus or like this, whatever the summary part is there, that we are not going to focus because that is not required for when you are going to apply multiple regressions. If you are focusing only one thing miss, then those things comes under picture. If you are going with multiple miss, those things are not required. Is that clear? Yeah. Just observe the interview question.